Here's the introduction and the lesson 11.5 about using intercepts. In this lesson, we're going to be discussing how to use the intercepts, how to graph from them, and how to find them. So let's go ahead and get started. Here's a little caveat or a little sidebar to what we're doing in this lesson. This is going to be graphing lines that are x equals and y equals. And as you can see, I've already started up at the top my tables. And when we graph, we have several different ways to do this, but for us graphing beginners, we're going to use a table to begin with because it's just a really easy way to visualize what we're actually doing. We're creating these tables so that we can create points that we can put on our graph and just say a definite, okay, the line goes through this point, it goes through this point, it goes through this point. So I'm going to use blue for my domain. Now, normally I can pick my domain. In this one, because y equals something, this is in y equals mx plus b form, we just happen not to have an x. I can pick my domain. And so I'm going to pick something really easy. -1, 0, and 1. I've got something negative, a little bit of something positive, and 0 is always a quality choice. Okay, and so what this graph is telling me is that y is equal to 5. It's not saying anything about the x. So it doesn't matter what the x is. Y is equal to 5. And so if x happens to be -1, y is 5. If x happens to be 0, y is 5. If x happens to be 1, then y is 5. And so when I start to plot these points, I've got -1 and it's 5. And so -1 goes to 5, 0 goes to 5, 1 goes to 5. And so even out here, all of my y values are going to go through 5. It doesn't matter what x is. And so if I go ahead and graph this, then I've got a line that simply goes through the place where y is equal to 5. Okay? So there's my straight line that goes through y equals 5. So no matter what x is, y is equal to 5. Those arrowheads mean that it continues on into an infinity. So at x equals 100, y is still equal to 5. A little bit different situation over here. And I'm going to go ahead and say that I'm going to start with the range because y is not dependent on anything. There's no y in this problem. And so when we're discussing the domain, we can't do so without understanding that x is equal to -4. And so if x is equal to -4, I can fill that in. But you're saying to yourself, can't you choose what x is? Well, in this case, no, because it's telling me, hey, x is equal to -4. And so then if I look at my y and I say, how does y react to what x is? If y is -1, x is still equal to -4. If y is 0, x is still equal to -4. If y is 1, then x is still equal to -4. And so when I go to plot this, I'm going to go to x is equal to -4, and I'm going to plot my points at 0, 1, and -1. Well, I've got news for you. It doesn't matter what y is. It keeps going on and on. Okay? And so when I graph this line, it's going to be a vertical line. It's going to say, hey, every value on there is x is equal to -4. And so as we explore this concept of using intercepts, it's important to remember that these two things are true. So y equals is going to be a vertical line. No, y equals is going to be a horizontal line. X equals is going to be a vertical line. So here we go. The concept of intercepts. I've got two columns here, intercepts, finding them. The x-intercept, I'm going to go ahead and put down the definition for this. The x-intercept is where the line of the function, so when I graph my function, crosses the x-axis. And this makes sense because if it's crossing the x-axis, that's where it's intercepting the x. It's intercepting the x right there. So if you guessed it, this is where the function crosses the y-axis. This shouldn't be too much of a mystery to us. when we look at what it means to intercept something. If you intercept a football, it's where you and the football cross paths and you catch it. And so if we're talking about the x-intercept, we're saying, where does this line touch the x-axis? The y-intercept is where does the line, this function, touch the y-axis? So to find them in this column over here, how do we find that? Well, when it's touching the x-axis, here's the x-axis. If a function is touching the x-axis, what does x equal? What does y equal? That's what we're asking. And so right here, y equals 0. Because it's at the x-axis, that's y equals 0. And so if I understand what that means, if I'm going to find the x-intercept, I'm going to substitute y equals 0 into the function equation. Because right here, y equals 0. It's at its lowest point in the positive realm. It's at y equals 0. And so if I look at a graph here, and I've got another function graphed, and I ask myself, what's happening when it intercepts the y-axis? And once again, this is the y-axis. What's happening right here? Well, that's where x is equal to 0. So in order to find the y-intercept, I substitute x equals 0 into the function equation. Okay, I'm substituting in those things in hopes that it will help me find these intercepts. Okay, so it's opposite. To find the x-intercept, you put in y equals 0. To find the y-intercept, you put in x equals 0. So here we go. We're going to find the intercept of the graph of y equals 1/2 x minus 5. So if we are going to do this, step 1, to find the intercept. Which one? Well, it says intercepts, so I would go ahead and write down this example because we're finding the intercepts. So for step 1, let's find the x-intercept. Okay? Code word, let y equals 0. So if I come down here and I say y equals 1/2 x minus 5, I'm going to substitute in 0 equals 1/2 times x minus 5. I'm going to solve for x now. So I'm going to add 5 to both sides. This goes away. 5 is equal to 1/2 x. 1/2 of what is 5? Well, x equals 10. Okay, so I substitute in y equals 0 and solve for x. So the x-intercept is going to be a point x equals 10. Now, let's find the y-intercept. So let x equal 0. Y equals 1/2 times 0 minus 5. Well, this one looks a little bit easier because the x is getting substituted in. So if x is 0, 0 times anything is 0, so y equals -5. That is my y-intercept. Is that y equals -5. Okay? And so knowing what this means, if I draw in my graph here, I can look at this graph and say, what does that actually mean? I've got my intercepts. And so my x-intercept is at x equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where it crosses, is over here. Okay? Where does my y cross? Where is my y-intercept? It's at -5. 1, 2, 3, 4, 5. Right here. Is it feasible to have a function that looks like this? I'm telling you, yes, it is. Because this is just where it crosses. And so it goes through both of these points. That's where it crosses those axes. That looks like an equation that we've done before. We got that simply by plugging in the values that we came up with. So it crosses at x equals 10 and y equals -5. Now, in the next example, take some time. Go ahead and pause the video right now. See if you can write down this example and find the intercept of the graph 3x plus y equals -1. I'm going to give you a hint. I'm giving you a hint. Solve for y equals mx plus b. Does anyone remember what that form is called? Function form or slope-intercept form. Very good. So go ahead and pause the video now if you would like and solve this example. I'll be right back with the answer. Okay, so I'm assuming you paused the video, or maybe you didn't, and you just want to see what it looks like to do this. And so we're going to find the x and y intercept. So x-intercept, y-intercept. Okay? So for x and y-intercept, we've got some things here. Now, for the x-intercept, we're going to let y equal 0. And so up here off to the side, I'm going to solve for y. So I'm going to say y equals -1 minus 3x, because I subtracted 3x from both sides. I'm going to reorder this. Y equals -3x minus 1. Okay? So if y equals -3x minus 1, I'm going to substitute in y equals 0. So 0 equals -3 times x minus 1. So 1 is equal to -3x. I'm going to divide by -3. And so x is equal to -1/3. A lot of you hate fractions. I know this. But just know, this is okay to have a fraction because it can intercept at somewhere that is not a whole number. So, in the next part, x is equal to 0. Y equals -3 times x minus 1. Okay, so y equals -3 times 0 minus 1. Well, this is y equals 0 minus 1. Y equals -1. These are good things for us because we have this ability to make this equation look like it does when we graph it using a table. We've got options now, people. This is great news. So y equals -1 here. Need the right writing utensil. Y equals -1 is here. X is equal to 1/3. Here. 2 points we can graph. Boom. Except you're saying to yourself, why did he do that? Even I confuse my negatives and positives sometimes. So those of you out there, you got it right and I didn't. -1. It should be -1/3. Always watch your negatives and positives. That's better. Okay, so y equals -3x minus 1. That's the graph of it using the intercepts. Now, before I start this one, I'm going to split up the video here. So go ahead and look for using intercepts video number 2. We'll pick up right here where this one left off.